Okay, so we're doing that problem that we just showed. I just drew a free body diagram just to show you guys like how you would set up a free body diagram, even though we don't really need it for this problem. If you're trying to find like the spring constant, like if it doesn't give you a spring constant, even though it did in this problem, you would set up your free body diagram, and then your net force equations. And this one there's no friction, so the only force is this. So again, that's why you don't need it. But yeah, you would just set up your free body diagrams, and then your net force equations equal that mass times acceleration, the difference in the forces, and then this spring force is always equal to negative kx. So if you have the displacement or the force, you can solve for the spring constant. Alright, so for this problem, it gives you spring constant, gives you displacement, it gives you mass. We're looking for velocity as soon as it leaves contact with the spring. When it leaves contact with the spring, we're assuming that's like the instant it happens, so that this displacement is going to be at its maximum, so it's going to be at 2. So we're going to use our energy equations like we talked about earlier to solve for this. So you just want to set it up. So it's going to be like a total change in energy. So potential energy at the beginning of the spring plus kinetic energy at the beginning equal to the potential energy at the end plus the kinetic energy at the end. This is going to go away because at the beginning, when displacement at its maximum velocity is 0, it's not moving because it's being compressed, so get rid of that. And at the end, potential energy is going to be 0 because it's lost contact with the spring, so this has its maximum velocity, this is 0. We write down the equations for potential energy is 1/2 kx squared, kinetic energy is 1/2 mv squared. And then we have like every single variable we need, so this problem is basically just a plug and chug after that. 1/2 times 300 times displacement is 2 squared is equal to 1/2 times, well, the 1/2s can cancel because they're both on the opposite sides of the equation. The mass is 10, velocity is what we're trying to find. So 304 is equal to 10v squared, 1200 is equal to 10v squared, 20 is equal to v squared. Square root of 120 is your velocity. So yeah, that's how you do that problem. That was a pretty straightforward problem, but yeah, basically the ways to solve any spring problem, you're just going to want to set up your free body diagram, look for an energy approach if you can. It's just like pretty much any other mechanics problem with you can like do an energy base or try Newton's laws.